Hello, I'm Hillary. Today I'm going to talk about how the market chain model can be applied in business. So, in today's world, businesses value predictability more than ever because being able to understand what might happen next can give companies a major advantage, whether it's forecasting customer behavior, anticipating equipment failures, or trying to make sense of financial trends. The ability to look ahead is incredibly valuable. And this is exactly where the market model becomes useful. It provides a straightforward mathematical way to describe systems that move from one connection to another over time. To give you a simple way to picture this, imagine a forgetful superhero is traveling between four cities that are connected by train tracks. Every time they decide where to go next, they look only at the city they're currently in and then randomly pick one of those outgoing train tracks. They don't remember where they came from and they don't try to avoid repeating cities. They just make their next move based on their current locations. And the basic idea making decision based only on the present moment is the essence of what a market chant is. And in business, this way of thinking helps us predict that what might happen next with our customers, machines, or even financial markets. So now let's talk a little more about what a market chain actually is. A market chain is essentially a sequence of potential events, and we call each event a state. What makes market chain unique is something called the market property, often described as the model being memoryless. This means that the probability of moving to the next state is based only on where the system is right now. It doesn't take into account how the system got there or what happened in the steps before. The entire history is ignored, only the present matters. A very simple way to look at this is to imagine yourself at a fork in the road. The path you choose next depends only on where you're standing right now. It doesn't rely on the path you walked it 5 minutes ago. In our superhero example, once the hero reaches city B, it doesn't matter whether they came from A, C, or D. They simply choose from the available tracks, leaving B. We see the same kind of idea in weather models. If today is sunny, the market model predicts tomorrow weather based only on today's condition, not yesterday or last week's. And this focus on the present is what makes the model simple enough to use but powerful enough to help with real forecasting. To actually use the market chain in business, we need to define those two main pieces. The first piece is the set of states, basically all the different conditions the system can be in. In a subscription business, the states might be active subscriber, disabled, or churn. In a brand competitive setting, the states might be customer of brand A or customer of brand B. In our previous example, the states are simply cities A, B, C, D. The second piece is the set of transition probability, which we organize into something called a transition matrix. This transition matrix tells us the probability of moving from one state to another. Each row represents where we are now, and each color represents where we might go next. For example, if we look at a very simple stock market model with two states, bull market and bear market, historical data might tell us that if this week is a bull market, there is a 75% chance that next week is also bull and a 25% chance that it will switches to bear. If this week is bear, there might be a 60% chance it stays bear next week and a 40% chance it becomes bull. And once we have this probability arranged in a transition matrix, we can use something as simple as metric multiplication to predict the state of the system, not just for 1 week from now, but many weeks ahead. And it allows us to estimate long-term behavior and trend, which is incredibly useful for planning and strategy. One of the strongest and most practical applications of market chain is in understanding customer behavior. So in a subscription service, the movement of the customer from active to disabled is essentially the churn rate. And the movement from disabled back to active is called the activation rate. And these are transition probabilities. Tracking this number allows companies to understand not just how many customers they have today, but how many they're likely to remain active in the future. And this lets them forecast their customer base months ahead and estimate something called customer lifetime value. Marketing are also extremely helpful in market share analysis. We can think of customers switching between brands the same way the superhero switches between cities. If brand A knows the probability of customers switching to brand B and also the probability of customers switching from brand B to brand A, it can use a transition metrics to estimate its long-term market share under current conditions. And this helps manager make decision whether to prioritize retention or acquisition. Every strategy they choose essentially changes the transition probability, which in turn changes the long-term outcome. So you can see there are two picture here. On the left side of the slide, we have a example of how a market chain can be used to understand the delinquency in account receivable. Each circle represents a different status an account can be in. So we have current, 30 days past due, 60 days past due, or bad debt. And the arrow shows the chances of moving from one status to another in the next month. So for example, if the account is current, most of the time about 90% it stays current, but a small percentage start to fall behind. Some may go into 30 days past due, and very small amount of portion may even jump straight to bad debt. If the account is 30 days past due, you can see on there is still a good chance it will repair itself or return to current. But there are some accounts continue to worsen and become the 16 days past due. From 16 days past due, accounts have about a 15-50 chance of either recovering or heading to a write-off. And once something becomes bad debt, only around 40% accounts ever recover from that state. By multiplying these probabilities across multiple periods, a company can estimate how much of its receivable will eventually be written off. And this helps the business plan its loss reverse, predict cash flow, and decide how aggressive it should be with collections. And on the right side, we have a different example using a stock price movement. In this case, the system has just two states: price up or price down. And the arrows show whether the trend tends to continue or reverse. If the price is currently moving up, there is a 70% chance it keeps going up in the next period and a 30% chance it drops. If the price is moving down, there's a 60% chance it keeps moving down and a 40% chance it goes back up. Trader can use this transition metric to estimate the momentum. And by multiplying the metrics with itself, they can look multiple days ahead and answer questions like, what are the chances that stock is still going up 3 days from now? What happened over the long run if those probabilities stay the same? So, of course, those models, they don't explain the reason behind those prices change, but they provide a mathematical base estimations of our next movement based on the current trend. Another area where market trends are useful is in manufacturing and operations. Here, the system might have states like fully operational, minor fault, or failed. By measuring the probability that a machine moves from one condition to another, companies can predict when failures are likely to happen, and this allows them to schedule maintenance before breakdown occur, which reduces downtime and keeps production running smoothly. They can also estimate how many defective products might come off the line if the machine is operating in a state that isn't ideal. And all of this helps companies plan resources more effectively and avoid expensive interruptions. Even though the market chain is incredibly useful, it's not perfect, and it's important to be aware of those limitations. The first major assumption is that all customers share the same transition probabilities. The model treats the entire customer base as one group, assuming everyone behaves the same way. But we know in real life, customers vary a lot. New customers behave differently from older ones, and some segments are more loyal than others. The second assumption here is that the probability stays constant over time. And in practice, the churn and reactivation rates change as people become more familiar with the product or as seasons, promotions, economy conditions shift. When the real probabilities drift, the accuracy of the model starts to break down. The third assumption is that the process is memoryless. The model assumes the future only depends on the current state, not on how long someone has been in that state. The duration matters. Someone who just churned yesterday might come back, while someone who's been disabled for a year almost never does. And finally, there is a know why problem. The model is great at predicting what might happen next, but it can't tell you the cost behind the transition. If the machine has a 20% chance of failing next week, the market won't tell you whether the real issue is poor lubrication or faulty parts. If churn slowly increases, it won't tell you whether it's because of pricing, customer dissatisfaction, or the competitor. So overall, the market trend is extremely helpful for a high level forecasting, especially when you want a rough picture of the future based on where things stand today. But it still needs to be paired with deeper analysis to understand why those transitions happen.